Okay, this video is about finding the inverse of a 2 by 2 matrix. Okay, so what's special about the inverse of a 2 by 2 matrix is that if you do any matrix, let's call it M, and you multiply it by its inverse, you get the identity matrix, and that identity matrix is 1 0 0 1. Okay, and the method for doing that is if you've got a matrix which has the elements A, B, C, D in it, then the inverse to that matrix, now the way that we write inverse, we put a little -1 there, is 1 over the determinant, which we worked out last lesson. So 1 over the determinant of this, and remember the determinant is AD minus BC, that gives you the determinant, and then you multiply that by, and you sort of switch some of the elements around and change their signs. So you swap the A and the D, so the D and the A get swapped over, and you reverse the signs of the C and the B. Okay, now you can only find the inverse of a matrix, 2 by 2 matrix, if that determinant is not equal to 0. In other words, when we say it is non-singular. If this is equal to 0, then if you try and do 1 divided by 0, your calculator is going to say no and come up with maths error, okay, because it's undefined. And if it is equal to 0, we call it singular. So basically it's just a single matrix on its own. It doesn't have a inverse partner to go with it. So let's do an example. So if I pick the matrix 3 2 -1 1, and I want to find the inverse of that, so the first thing I need to do is to find the determinant of that matrix. Okay, so remember you can write it down like this, that 3 2 -1 1 inside the little brackets like that. You can do it on your calculator, but it's easy enough to do in your head. So it's that times that minus that times that, so it's 3 minus -2, so that becomes 5. Okay, so it's non-singular, so we know we can find the inverse of it. Okay, so 1 over 5, 1 over the determinant, and then in the brackets we're going to swap over these two, so 3 and 1 becomes 1 and 3, and we're going to reverse the signs of these two, so that becomes 1 and this becomes -2. Okay, now what we can do, you can multiply everything in here by 5. You can leave it like this, or you can write it as 1/5 minus 2/5 minus 1/5 and 3/5. Okay, so all I've done is just put the 5th inside, multiply everything by 5, and this is the inverse to this matrix. Now if I were to multiply this matrix by its inverse, and we might do that now, 1/5 1/5 minus 2/5 3/5, we should get the identity matrix. Okay, so we're going to do that times that plus that times that, so this is 3/5 plus 2/5, which is 1. Okay, so we did that times that times that. First row, first column goes here. So if I do the first row by the second column, so if I do that times that plus that times that, so that times that is -6 over 5, and then this times this is 6 over 5, so -6 over 5 plus 6 over 5 is 0. All seems to be working out so far. So if I do this times this plus this times this, bottom row first column, so bottom row first column here, so this is -1/5 plus 1/5. Okay, so that's going to be 0, and then -1 times -2/5, so that's 2/5. So we've got 2/5 plus 3/5, and 2/5 plus 3/5 is 1. So there you can see it works. So that's how you find the inverse of a 2 by 2 matrix. There's also some other stuff in that section as well, where it says that, and this is a useful rule, that if you multiply two matrices then find their inverse, that is equal to the inverse of the second matrix times the inverse of the first matrix. Yeah, that's a useful rule, that multiply two matrices together first, then you find their inverse. Okay, that is equal to the inverse of the second matrix here times the inverse of the first matrix. That's useful for sort of changing things around. You can also sort of change this around. There's another rule that sort of says, you know, if you've got two matrices like that, A times B, and you multiply them by the inverse of those two matrices, you get the identity. Yeah, and any type of matrix equation you've got, if you multiply both sides by the identity, you can do that. You can take rules like this and multiply the both sides by something, as long, if I multiplied like this side by a matrix C and I put it at the front, then I must put that matrix C at the front here. If I multiplied by another matrix D and I put that here, then that one must go at the end here. The order matters. You mustn't change them around. Remember what we said was AB is not equal to BA. So if I decide, right, I'm going to multiply that, and I need to do the same thing here. Okay, so an example might be if AB equals a matrix M, then another matrix CAB equals CM. So notice how the C has gone at the front. Okay, and also, as I said, you can multiply by the identity. It leaves things unchanged. So I could say, right, AB times the identity matrix is going to be, well, if AB was M, then ABI is also M or MI, because remember, that leaves things unchanged. You multiply by the identity and it leaves things unchanged.